Let us look at proposition number 8 of works of Archimedes, specifically from book 2 of On the Sphere and Cylinder. The proposition says, if a sphere be cut by a plane not passing through the center into two segments, A prime, BB prime, and ABB prime, of which A prime BB prime is the greater, then the ratio segment A prime BB prime is to segment ABB prime is less than the square of surface of A prime BB prime is to square of surface of ABB prime, but greater than surface of A prime BB prime to the power of 3 by 2 is to surface of ABB prime to the power of 3 by 2. So let's see what all this means and how to prove this. Given a sphere cut by a plane not passing through the center, O, this plane is not passing through the center and it is cutting the sphere into two, where A prime BB prime segment is greater. Take a great circle perpendicular to the plane with diameter AA prime and intersecting the plane at BB prime. And the plane cuts the diameter AA prime at M. So let's do that. So AA prime is the diameter of the great circle. The plane intersects this great circle at BB prime. And the plane also intersects the line segment of the diameter A prime at M. Now join A prime B and AB, and let's join BB prime as well. Now take H on OA extended such that OA prime plus A prime M is to A prime M is equal to HM is to AM. So you know by now where we are heading. Again, take H prime on OA prime extended such that OA plus AM is to AM is equal to H prime M is to A prime M. Now, there is a circle of intersection between the plane and the sphere. Draw cone HBB prime with base as the circle with diameter BB prime and height equal to MH. Again, draw cone H prime BB prime with base as a circle with diameter BB prime and height equal to MH prime. Take K on H prime A prime such that OA prime is equal to A prime K. Take N on A prime A such that A prime N square is equal to A prime H prime times A prime K. So again, we have A prime H prime, we have A prime K. So we have to find AN, which is pretty straightforward. So let's take N. Segment A prime B B prime. The segment of the sphere A prime B B prime is to segment of the sphere ABB prime is less than surface of A prime BB prime square is to surface of ABB prime square. This is what we have to prove. Segment A prime B prime is to segment ABB prime is greater than surface of A prime B prime to the power of 3 by 2 is to surface of ABB prime to the power of 3 by 2. Again, this is the second part that we have to prove. Now that we have constructed these cones, we know that cone HBB prime is equal to segment of the sphere BAB prime. Similarly, cone H prime B prime is equal to segment of the sphere BA prime B prime. And we know that cone HBB prime is to cone H prime BB prime is equal to HM is to H prime M. Why? Because cones with the same base are proportional to their heights. So here HN and H prime M are the heights. And we also know that the surface of A prime B B prime, that is surface of the segment of the sphere A prime B B prime, is to surface of A B B prime is equal to A prime B square is to AB square. And surface of A prime B B prime is to surface of A B B prime is equal to A prime M is to AM. Why? Because A prime B square is to AB square is equal to A prime M is to AM. These ratios are same. So which means H prime M is to MH is less than A prime M square is to AM square. This is what we have to prove as far as the first part is concerned. So let me hide this plane because it's... So the first part, we can prove it by proving this inequality. Similarly, H prime M is to MH is greater than A prime M to the power of 3 by 2 is to AM is to the power of 3 by 2. The second part, we can prove it in this way. If we are able to show this, that means we have proved the proposition. So now let's take it one by. This is how we constructed it. OA plus AM is to AM is equal to H prime M is to A prime M. If we do dividendo, we get OA plus AM minus AM is to AM is equal to H prime M minus A prime M is to A prime M. So AM gets cancelled out. OA is to AM is equal to H prime M minus A prime M. H prime M minus A prime M gives us A prime H prime. So is equal to H prime A prime is to A prime M. We know that OA is equal to OA prime because O is the center. So that means OA is equal to OA prime. A prime M is to AM is equal to A prime H prime is to OA prime. Here A prime M is greater than AM. Why? Because remember we said that this plane cuts the sphere into two unequal parts where this part is greater than this part. So that is why A prime M is greater than AM. Which implies because of this proportionality that A prime H prime is greater than OA prime. What that means is K falls between H prime and A prime. Now let's take the first equation. OA prime plus A prime M is to A prime M is equal to HM is to AM. Now OA prime is equal to A prime K. So we substitute it and we can say A prime K plus A prime M is to A prime M is equal to HM is to AM. Now A prime K plus A prime M is nothing but Km. So Km is to A prime M is equal to HM is to AM. Rearranging it, we get Km is to HM is equal to A prime M is to AM. Km is to HM is equal to A prime H prime is to OA prime, but OA prime is equal to A prime K. So Km is to HM is equal to A prime H prime is to A prime K. So now if we substitute this A prime H prime is to A prime K by H prime M is to MK, this equality becomes inequality. Km is to HM becomes greater than H prime M is to MK, which means H prime M times hm is less than mk square or km square. Remember, product of extremes and product of means. So first comes the extremes. Now here we have taken the means first. So the sign changes to less than. H prime m times hm is to mh square is less than km square is to mh square. So what did we do here? We divided both the sides by mh square, or in other words, we have taken a ratio of both the sides with the same magnitude. Now h prime m is to, now here hm and hm, here it gets cancelled, here one of them gets cancelled. So h prime m is to mh is less than km square is to mh square. Now km, where is it? Km is to hm is equal to a prime m is to am. That means km square is to hm square is equal to a prime m square is to am square. So that means we can substitute km square is to mh square with a prime m square is to am square. So we end up with h prime m is to mh is less than a prime m square is to am square, which is what we had to prove. Let's look at the second case, which says h prime m is to mh is greater than a prime m to the power of 3 by 2 is to am to the power of 3 by 2. A prime m times am is less than a prime o times oa, which we can write it in the form of a ratio, inequality in ratios. A prime m is to oa prime is less than oa is to am. Now from 2 we have oa plus am is to am equal to h prime m is to a prime m. Now if we carry out dividendo, we get oa plus am minus am is to am equal to h prime m minus a prime m is to a prime m, which gives us oa is to am is equal to a prime h prime is to a prime m, because h prime m minus a prime m gives us a prime h prime. OA is equal to OA prime, both are radius. So OA prime is to AM is equal to A prime H prime is to A prime M. A prime M is to OA prime is less than A prime H prime is to A prime M, because these two are equal. So we can substitute OA is to OA AM with A prime H prime is to A prime M, which gives us A prime M square is less than A prime H prime times A prime O. Remember, we had taken n such that A prime n square is equal to A prime H prime times A prime K, which implies that A prime H prime is to A prime n is equal to A prime n is to A prime K, because A prime n is the mean proportional between A prime H prime and A prime K. Now let's carry out componendo on this. A prime H prime plus A prime n. A prime H prime plus A prime n gives us H prime n. So H prime n is to A prime n is equal to A prime n plus A prime k, which gives us nk is to A prime k. A prime H prime is to A prime k is equal to A prime n square is to A prime k square. How did we get this? A prime H prime is to A prime n is equal to A prime n is to A prime k. We took this proportion and we multiplied both these two sides by A prime n is to A prime k, so that we end up with this. Now h prime n is to nk is equal to a prime n is to a prime k. Squaring both these two sides, we get a prime n square is to a prime k square is equal to h prime n square is to nk square. Okay. Now h prime a prime is to a prime k is equal to h prime n square is to nk square, because here we have h prime a prime is to a prime k is equal to a prime n square is to a prime k square, but a prime n square is to a prime k square is equal to h prime n square is to nk square. So we have done the substitution. H prime m is to mk is greater than h prime n is to nk. Now squaring both sides of this inequality, we get h prime m square is to mk square is greater than h prime n square is to nk square. But that is equal to h prime a prime is to a prime k. H prime m square is to mk square is greater than h prime a prime is to oa prime, because a prime k is equal to oa prime. That means h prime m square is to mk square is greater than a prime m is to am, because here if you notice a prime h prime is to oa prime is equal to a prime m is to am. So we have done the substitution. So which means h prime m square is to mk square is greater than oa prime plus a prime m is to mh. Why? Because a prime n is to am is equal to oa prime plus a prime m is to mh. So h prime m square is to mk square is greater than km is to mh, because OA prime plus A prime M, since OA prime is equal to K prime, A prime K, we can say Km by adding these two. So Km is to MH. Now H prime M square is to MH square can be written as H prime M square is to MH square times Km square is to Km square. So basically, we are multiplying and dividing this ratio with km square, and this can be rearranged in this form. H prime m square is to km square times km square is to mh square. That means h prime m square is to mh square is greater than km is to mh times km square is to mh square, because here we have h prime m square is to mk square is greater than km is to mh. So by substituting this, we are making it as an inequality. So h prime m square is to mh square is greater than km cube is to mh cube. H prime m is to mh is equal to km to the power of 3 by 2 is to mh to the power of 3 by 2 by taking the square root on both the sides. So these squares will disappear because of the square root. And here we will end up with 3 by 2 and 3 by 2, which is what we had to prove, that h prime m is to mh is greater than a prime m to the power of 3 by 2 is to am to the power of 3 by 2. And we should not forget that by proving this, what we have actually proved is segment a prime b prime is to segment a b prime of the spheres is less than surface of a prime b prime square is to surface of a b prime square. That is, the ratio of the volumes of these spherical segments is less than the surface area squares of these two segments. Similarly, the volumes of these two segments is greater than the surface of a prime b prime to the power of 3 by 2 to the surface of a b prime to the power of 3 by 2. So that is proposition number 8 of works of Archimedes, specifically from book 2 of On the Sphere and Cylinder. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.